Now that we've talked about the basic features in completable futures, let's go ahead and focus on the advanced features. And we'll start by talking about the so-called factory methods. And the factory methods are the key entry points into the completable futures framework that begin asynchronous computations. And you'll see there's a bunch of different factory methods. So there are 4 factory methods. They're the things that set the wheels in motion, as per the visualization there. And they're basically implementing the factory method pattern. You probably, hopefully remember that from the design patterns course we teach here, CS 3251, where the factory method is a way of creating something, and it shields the client of the factory method from the details of how things are made, so you can just worry about using the product that is returned from the factory method. In this case, there's a couple of different variants for factory methods. These computations that are set in motion asynchronously may or may not return a value. So we'll see there are some methods, such as supply async, that allow you to invoke 2-way asynchronous calls via a supplier, if you remember the functional interface supplier. And these are 2-way operations. What that means is that whatever you're invoking to run asynchronously will ultimately return a value that you can do something with in a later part of your code, as we'll see in a second when we talk about completion stage methods. There, as you can see here, there's a couple of different variants of the supply async method. One of them uses the common fork join pool to do the computation, and the other one allows you to give it a particular executor, which could be a fixed size thread pool, it could be a cached thread pool, it could be some custom thread pool. It's up to you to decide what you want to do. Usually people use the default one that runs in the common fork join pool that we've talked about a couple times before. You can pass supply async some values using the magic of effectively final variables and lambda expressions, as we'll see here. And of course, it returns a value because it's a 2-way call. So here's a simple example. We've seen a variant of this before. This time, instead of making a new thread and starting it, however, we're going to say CompletableFuture.supply async, and then we give a lambda expression here that will create 2 big fractions from some effectively final string variables up here, and then multiply them together. And you can see here that F1 and F2 are treated as effectively final. And that's because between the point when they're set and when they're used, they aren't changed. Even though these are not explicitly defined as final, they're effectively final. There's also another pair of factory methods called run async. And the difference between run async and supply async is that supply async provides 2-way call semantics where there's a return value that comes back, whereas run async is a 1-way call, just a single parameter going in. Once again, in this case, it takes a runnable, and there are 2 variants, one of which will use the common fork join pool to execute the runnable computation that doesn't return a value, and the second of which will use the executor pool of your choice to run that computation in the background and not return a value. Here's an example of doing this. This is run async instead of supply async, and you can see we have a return value of void, which is sort of says there's no return value. It's just kind of a placeholder syntactically in the Java language. And down here you can see how that means there's no value coming back, and you can also see that we have to have results. To the extent that there's results you want handled or dealt with in some way, you have to do these through a side effect rather than a return value. So in this case, we're going to have the side effect of printing the values out to the standard output, but we don't have a return that comes back. So just a simple example. Just as a quick rule of thumb, I almost never use run async. I almost always use supply async, and that's because the whole purpose of completable futures in the completable futures framework with the advanced features is to chain together the return results through these things called completion stage methods that we'll talk about in a second. As I mentioned before, the async functionality runs in a thread pool, which can either be the common fork join pool or something you can give explicitly that as long as it abides by the executor interface. So let's re-look at our previous example, except this time we're going to use the factory method supply async instead of making our own thread. You'll see this example is very, very similar to what we had before. We're going to go ahead and create a, we're going to call supply async, and that says schedule the stuff in here for subsequent execution in a thread in the common fork join pool. And you'll also notice that unlike the previous example, remember the previous example, we created a kind of a placeholder future at the top, and then we did a complete call in the Lambda expression to complete its value when it finished. Because we're using supply async, and because supply async returns a completable future, we don't have to play those kind of weird placeholder games anymore. So in this case, we're going to say completable future, big fraction future is assigned the result of calling completable future supply async. So supply async is going to return, as we'll see in a second, a completable future to a big fraction. And so all it has to do is just provide the computation to perform. And in this case, when that computation is done, running in the background, it will simply return the result. And that will be hooked up with the completable future that comes back here. If you're curious how supply async works under the hood, you can go back to one of the very early videos we did, probably maybe in week 2, when we were talking about the various functional interfaces in Java 8. And I had talked about supplier. That was one of the functional interfaces we talked about. If you go back and watch that video, which was from a long time ago, you'll see I actually kind of walked through the behavior of what happens when a supplier is given to supply async. And what it does under the hood is it takes that supplier and it wraps it up in a little helper object called, I think it's like async result or something. And it has that async result put into a queue, and then a thread in the common fork join pool will pull that result off the queue and then go ahead and execute that, which will cause this supplier's get method to be called in the context of a background thread from the fork join pool that will run to completion and update the result of the future that came back here, the completable future that came back. So if you want to see kind of how it works, there's a video earlier that walks through those steps. These computations run concurrently, just as we saw before, and also as before, you can join up with the results if you so desire. So this is a little bit better than the previous example, the one that used futures. In particular, we don't have any Java threads here. You'll see that we don't have to do the threads. We don't have to do all that wacky stuff with the completed future where we complete it and so on. So it's a little bit better, but it still isn't really leveraging the full power of the completable futures framework advanced features. So that's what we're going to talk about next, are the really powerful features in completable future, which, as you'll see, are the completion stage methods.